Hello and welcome to another Physical Sciences 3 lecture. We're starting off with Criterion 5 today, which is one of the physics units, forces and motion and momentum there in brackets, and it's got these pictures on the front cover. Scrolling through the contents there. Okay, we're starting off this unit with scalars and vectors. Scalars and vectors. So an example here is if you were bushwalking and someone asked you for the air temperature, you'd be satisfied to be told 5 degrees Celsius. However, if you were asked how to get to the next hut and you were told to walk for 5 kilometers, you'd be very unhappy if you then walked 5 kilometers north, but the hut was actually 5 kilometers east. And this is an example of a scalar versus a vector. So a scalar is one of these 5 degrees Celsius, and a vector is an example of, or 5 kilometers east is an example of a vector. So direction can be very important in specifying physical quantities. For this reason, physical quantities are broken down into two categories, scalars and vectors. And the main difference between scalars and vectors is that vectors, they have a direction, just like in the example up above, whereas scalars have no direction. They just have a magnitude. So magnitude is a size and a unit there. But as you see over here, vectors also have a size and a unit as well. So some examples are listed here of scalars. So distance, speed, time, energy, volume, mass, power, temperature, and power. The reason that's listed twice is because there's two types of power, mechanical power and also electrical power. And we talk about them later in the course. Okay, so in a vector we have displacement, velocity, acceleration, force, weight, and momentum. Okay, so distance and displacement, they are similar but not the same, and speed and velocity are also similar but not the same, and we will talk about them a bit more later on also. Okay, so further some of the notation, if you see, particularly in textbooks, they might have this kind of notation. So as you see that scalars, they just use normal letters, normal pronumerals, whereas vectors have these little arrows above their head. Here, these little arrows there. And just like before, these are some scalars here. So time is 90 seconds. Power is 2000 watts. Whereas if we have our vectors over here, we have force, which is equal to 5,000 newtons east, and acceleration, which is 27.5 meters per second down. Okay, so just notice that they have those directions on the end there. Okay, just a quick note here though. While in theory, so this note here, while in theory all vector pronumerals should have an arrow above their head, so should have an arrow like that above their head. In practice, this is quite laborious, so it's quite time consuming. And with familiar quantities, the arrow is often omitted. So rather than force, you'll most likely just write force with an F, and I'll do it all through the lectures. I'll just write like this. So that is equal to force with a little arrow above its head. Same with acceleration, I'll just write that with a little A, which is also equal to A. So technically, all vectors should have little arrows above their heads to signify they are a vector, but quite often people will leave them out, and you'll get used to that as you go. Okay, so what we can do is add and subtract scalars and vectors. So if you look at scalars to start off with, it's just the same as our normal addition and subtraction. So if we had the mass of a beaker plus salt, okay, is this number here, 179.6 grams, and then we have the mass of an empty beaker, which is 153.06 grams. What we can do is just simply subtract this mass away from this mass, and we find the mass of the salt, mass of salt. Or you could just see that's written there. I don't know why I wrote that again. Never mind. Ooh, and the thing's going with me. I'm not sure about that. Hopefully it stops there. Okay, addition of vectors. So addition of vectors is slightly different because of the direction. So we can't just add the magnitudes together like we normally would. What we end up when we add two vectors together is a resultant vector. Okay, and so it's what happens when we combine the two vectors together. So we'll have a look at examples, and the resultant vector will become quite clear. Here are some steps for you to when you're adding vectors in one dimension or two directions. So we always need to assign one of the directions as positive. For example, if we had north versus south, usually north would be positive. North is positive. But there's nothing stopping us from saying that south is positive either. So we can define whichever one is positive or negative, and sometimes it will be more useful to say that south is positive. So that's one of the great things about vectors, is we can actually assign whichever direction we like as the positive one and whichever one is the negative. And we usually start our problems by writing which one is positive. So here's a sample problem here. If we have the weight of a skydiver is 750 newtons, okay, and the force of air resistance is 500 newtons up, calculate the resultant force, F net, on the skydiver. Now, just before we look at this problem, weight here, as we'll come to know in this course, weight is actually a force and measured in newtons, compared to, say, what everyday usage of weight is usually in kilograms. But this is kind of like a misconception of what weight actually is. When you are measuring the weight as you know it, you're actually measuring your mass, and the scales actually convert newtons into mass for you, and so kilograms are just much easier for us to work with, and that's what we use on a daily basis. And we're going to talk a lot more about that during the course as well. Okay, so an example for us to work on. There's a couple of examples now, and I think I'll make some more videos for those ones. So we'll do some numerical videos next.